What's up, everyone? Rosario here, and welcome to Modern Finance. What's the meaning of life? What's your purpose in life? I know my purpose, and the purpose of this channel is to help you understand what you can invest in to help me grow my wealth and help you grow your wealth, and for both of us to prosper and grow together. A friend sent me something today, and I could not make a video about it because it's so terrifying and potentially so exciting. I don't really understand the ramifications of it myself. What this could represent is a complete paradigm shift in what we view as the fundamental responsibility and the function of humanity. I'm not saying this lightly. If what this article says is actually true, humanity is basically useless. We're not going to be able to do anything functional. Maybe I'm totally wrong about this. Make sure you check out the article yourself and listen to this video so you can hear my thoughts on it, what it could represent for the next 5, 10, 15 years, and how you could actually profit from this article if you understand what they're saying and are prepared to invest in this technology. So without further ado, let's begin. Here is AlphaCode, and if you're not familiar with AlphaCode, it's a branch of DeepMind, which is Google's machine learning and artificial intelligence division. This is their division that already produced things like AlphaGo, which destroyed the game of Go, which is a more advanced Asian version of chess that is thousands of years old and was able to defeat the top human level players decades before other AI researchers thought that this would be possible. When Google and AlphaGo and by proxy AlphaCode says they've done something, I tend to take it seriously. So let's jump in and see what they say that they've been able to do. So the title is pretty ambiguous. It says, solving novel problems and setting a new milestone in competitive programming. Okay, well, that sounds kind of pretty generic, but let's see when we dive into this, what does that actually mean? Creating solutions to unforeseen problems is second nature in human intelligence. Yeah, that's true. A result of critical thinking informed by experience. The machine learning community has made tremendous progress in generating and understanding textual data, but advances in problem solving remain limited to relatively simple maths and programming problems. So yeah, like that makes sense. Like it takes a human brain to figure out complex problem solving, and that's what we're good at. That's why I still have a job. It's probably why you still have a job. But let's just highlight that because that's what we think of as an advantage that humans have right now. Limited to relatively simple maths and programming problems. Or else retrieving and copying existing solutions. Typically, machines and AI aren't capable of coming up with novel solutions on their own, or they can only combine things and make new things from those combined things. Now, how much do humans do that? Pretty much everything that we see, every new invention is a derivative of some old inventions put together. But people who are skilled in the field are able to take that past knowledge and build on it. So what really is innovation? Like, is it the ability of people and machines to coalesce these ideas, or is it actually coming up with brand new inventions, brand new technologies with no background? Well, let's see what Google's trying to do here. In our preprint, we detail AlphaCode, which uses transformer-based language models to generate code at an unprecedented scale. So what does unprecedented mean? And also, what is transformer-based language? I don't exactly know what that means, so maybe they'll talk about it more in this article. And then smartly filters to a small set of promising programs. We validated our performance using competitions hosted on Codeforces, a popular platform which hosts regular competitions that attract tens of thousands. You heard that right. Tens of thousands of participants from around the world who come to test their coding skills. So it doesn't really seem like they're competing against little children here. They're competing against tens of thousands of people who want to prove that they're a good programmer. And Google is already cracking the top 50% of this competition. That's wild. We selected for evaluation 10 recent contests, each newer than our training data. So that means these contests are outside of the training data. So the program had never seen anything like or at least identical to these contests. AlphaCode is getting completely new data that they've never seen before, and they're able to jump in and solve it at 54th percentile, which is pretty impressive. Each newer than our training data, that's important to note. AlphaCode placed at about the level of the median competitor, marking the first time an AI code generation system has reached a competitive level of performance in programming competitions. Wow. Competitive level of programming. First time. My goodness. Are you getting scared? Because I am. Like, if they were able to do this quickly, what are people going to do as jobs in the future? Like, if programming and coding isn't a job, what are we going to do? Like, maybe we can all make YouTube videos, but like, holy crap, I'm scared. Like, I used to not think that universal basic income would need to be a thing. And I still don't like the idea of it because I think people need to have something that they're passionate about and feel like they're contributing to society to have a life that can be fulfilling. And this kind of puts a nail in the coffin for human productivity. What are we going to do if we can't even program? Like, sure, we could have a bunch of YouTube channels and talk about all the crazy stuff that these AI are doing, but at that point, like, are we really doing anything productive for humanity? I don't know. Let me know what you guys think down in the comments below, but that is pretty scary to me. To help others build on our results, we're releasing our data set of competitive programming problems and solutions on GitHub. So this is good. They're releasing their data set of competitive programming problems and solutions on GitHub. But does that mean that they're releasing the code for AlphaCode? I don't think so. Including extensive tests to ensure the programs that pass these tests are correct. Obviously, that's a critical feature that current datasets lack. We hope this benchmark will lead to further innovations in problem solving and code generation. Let's take a look at the kinds of problems that this software is hoping to solve or is already solving. I'm going to look at this and see if I understand anything out of it. Obviously, if you're not a programmer already, this might not make sense to you, but let's dive in. You're given two strings. So strings are just combinations of letters and numbers, basically. Let's see, two strings, S and T, both consisting of lowercase English letters. Okay, so they're just letters. There's no numbers. You're going to type the string S character by character, so that's the name of the string, from the first character to the last one. So if it's like type, that would be TYPE. That makes sense. When typing a character, instead of pressing the button corresponding to it, you can press the backspace button. Okay, so you can press the backspace button. It deletes the last character you have typed among those that aren't deleted yet, or does nothing if there are no characters in the current string. For example, if S is ABCD and you press backspace, instead of typing the first and fourth characters, you'll get the string BD. The first press of backspace deletes no character, and the second press deletes the character C. Another example, if S is ABCAA and you press backspace instead of the last two letters, then the resulting text is A. Okay, I see. Okay, so you're like typing it along. So you'd type A backspace B, that would be 3, and then the fourth would be C, and then you press backspace again, and then you type D. Okay, that makes sense how they're getting that. Hopefully you follow that logic because it's a little bit confusing. Okay, so your task is to determine whether you can obtain the string T if you type the string S and press backspace instead of typing several, maybe 0 characters of S. Okay, so basically you're trying to figure out if the string T can be gained if it's like a subset of the string S. The first line contains a single integer Q, and Q is greater than or equal to 1 and less than or equal to 10 to the 5th. Let's see if I can do this in my head. 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000, 10 to the 5 is 100,000. Okay, so basically it's between 1 and 100,000 test cases. The first line of each test case contains the string. First line of each test case contains the string S, and S is also between that size. Each character of S is a lowercase English letter. The second line of each test case contains the string T. Each character of T is a lowercase English letter. It is guaranteed that the total number of characters in the strings over all test cases does not exceed 2 times 10 to the 5th. So that's 200,000. Okay, now let's look at output. For each test case, print yes if you can obtain the string T by typing the string S and replacing some characters with presses of backspace button, or no if you cannot. You may print each letter in any case. Yes, comma, yes, comma, yes. Okay, so basically, I see what they're doing here. Like, it doesn't have to be case sensitive. Will all be recognized as a positive answer? No, no, and no will all be recognized as a negative answer. Okay, that's great. So here's some inputs. So we've got a bunch of different things, and then we see yes, no, no, yes as our outputs. Consider the example test from the statement. In order to obtain BA from A, B, A, B, A, you may press backspace instead of typing the first and the fourth characters. There's no way to obtain BB while typing AB, ABA. There's no way to obtain AAAA while typing AAA. Right, because it's longer. In order to obtain AB, ABA while typing AA, BA, BA, you have to press backspace instead of typing the first character. Then type all of the remaining characters. All right, so let's see what the solution for that AlphaCode generated looks like. Here's the code. And obviously I'll put the link to this in the description. So if you guys want to check out what exactly Google has done here, you can check out the link in the description below and read this for yourself and see if you can come up with solutions to these problems yourself and see if Google's smarter than you. I know right now I think I understand what this problem is trying to solve. I don't know if I could create a program quickly to solve it, but I think I could eventually create a program that would solve this. Might take a few days though. Okay, for t int input, so t equals int input, so there's an integer input that you're putting in. So for I in range t, s equals input, t equals input. First AlphaCode reads the two phrases, so they're getting A and B. If the letters at the end of both phrases don't match, the last letter must be deleted. If they do match, we can move on to the second last letter and repeat. Backspace deletes two letters, the letter you pressed backspace instead of and the letter before it. If we've matched every letter, it's possible, and we output that. Okay, so basically this isn't like really doing a mathematical proof. It's just kind of, this seems like a guess and check program to me if I'm understanding it correctly. Let me know down in the comments below if that is right. Yeah, so if we've matched every letter, it's possible, and we output that. That makes sense. So 1. AlphaCode is presented with a problem, in this case to figure out if it's possible to convert one phrase to another by pressing backspace instead of typing some letters. 2. AlphaCode reads the whole problem statement and produces code, analogous to how a human would approach the problem by reading it, coding a solution, and submitting. That's kind of crazy. So it reads the whole problem statement, produces code, and I guess codes a solution and submits it. So basically it's doing exactly what a human would do. It ingests the raw data, so like the text, the plain text of what the problem is, and then it produces code and submits it. Now, some of the questions that I have are, well, I think there will probably ones that come to your mind too, like who writes the problem? What I'm saying here is like, does it have to be written in a specific way for AlphaCode to understand it. If I just said, figure this out, does it understand sort of any type of natural language, or is it natural language that's specific to what you would typically see in these coding problems? Or is it looking at these coding problems that are always given to humans? Like, who's generating these coding problems, and how does AlphaCode interpret this text? Is this text written by a human? Is this text of the problem something that can be in any format, or is it in a specific format that AlphaCode then recognizes? So then it goes on to say, competitive programming is a popular and challenging activity. Hundreds of thousands of programmers participate in coding competitions to gain experience and showcase their skills in fun and collaborative ways. During competitions, participants receive a series of long problem descriptions and a few hours. So they have a few hours. So they have, I was wondering about that, they have a few hours to write programs to solve them. Typical problems include finding ways to place roads and buildings within certain constraints, creating strategies to win custom board games, and ranked mainly based on, so what are they ranked on? How many problems they solve. Okay, that's it. Companies use these competitions as recruiting tools. So I guess AlphaCode is going to be recruited by companies right now. And similar types of problems are common in hiring processes for software engineers. Does this mean AlphaCode can get hired as a software engineer? Like, can, and this is the Greek letter alpha, by the way, in my awful handwriting. So what I'm asking here is, can AlphaCode get hired as a software engineer today? Like, is there anyone out there who would actually look at AlphaCode's solution and be like, yes, this is good enough for me to hire you as a software engineer, even if it's an entry-level position? If that's the case, then what I was talking about at the beginning of this episode is seriously potentially true. If software engineers are being replaced by software in hiring, like, how far are we away from AlphaCode being able to beat the best humans? I can't imagine it's very far. Is there really something specific to human level intelligence that gives us an inherent advantage? Is an entry-level software engineer that different from someone who's at a high level coding for the top companies? Can AlphaCode create AlphaCode? That's my question. And if it can, what's the point of humans? All right, let's move on here and see what else they say. The problem-solving abilities required to excel at these competitions are beyond the capabilities of existing AI systems. That's interesting. So that's basically saying that we don't have the problem-solving ability to actually solve these. So how is Google actually mimicking or faking this problem-solving ability? So maybe this is where this turns around a little bit. By combining advances in large-scale transformer models that have recently shown promising abilities to generate code. Okay, so it's basically using whatever machine learning model this is to generate code. With large-scale sampling and filtering, we've made significant progress in the number of problems we can solve. So they pre-train their model on selected public GitHub code, fine-tune it to, okay, so some of the questions I have are like selected, like how much code is that? So let's just back out of here. So we've got selected. So how much? How much? And fine tune it on our relatively small competitive programming data set. Again, how big is relatively small? At evaluation time, we create a massive amount of C++ and Python programs for each problem, orders of magnitude larger than previous work. Okay, so they're creating a huge amount of code that might solve these problems and might do nothing. That's what I'm understanding. Then we filter, cluster, and re-rank those solutions to a small set of 10 candidate programs that we submit for external assessment, whatever that means. I'd like to know what is external assessment. So is that by a human or is that by another part of the AlphaCode software? This automated system replaces competitors' trial and error processes of debugging, compiling, passing tests, and eventually submitting. Okay, so if you read this from the beginning, you get really scared, and then you get to this point and you realize, oh, so basically they're generating a whole pile of crap, seeing which of that crap actually does something, and then submitting the pile of crap that's the least crappy out of the entire pile of crap, if that makes any sense. So they're generating a ridiculous amount of code, seeing parts of that code might actually work, and then taking that part of the code and submitting it. Is that as scary as I was saying at the top of this episode? Maybe. Maybe that's another way to be intelligent, is to understand how to game the system. It seems to me like Google's really gaming the system here. They're not really problem solving. They're just, that's what computers are good at though, right? They're dumping as much as they can, a whole bunch of computing power, at generating a whole bunch of crap code, and then seeing which of that code actually performs the best and submitting the ones that perform the best. I don't know about you, but I feel a little bit less scared than I did at the beginning of this. Let's continue and see what else Google has that's super scary in here. So we've got the data from GitHub. We've got the code contests that have the problems and solutions here, and that feeds into the learning model. So they've got the pre-training and the fine-tuning. This is kind of how the evaluation process takes place. So we've got the problems from code forces, so that's given to them. Then they have the large-scale sampling, and then they have a large set of potential solutions. So I'm wondering how big that is, large set of potential solutions. Then they do filtering and clustering. And this filtering and clustering is really the interesting part here. Like, how do they filter and decide which of these solutions are going to be effective? And then they have a selected small set of candidates where they said like top 10, and then they execute those and evaluate them. So if they're able to understand which solutions might not work really quickly, then this might be the same as problem solving. Is that what humans are doing in our heads when we're solving a problem? Are we just throwing out all the junk that we know won't work? Like, I don't feel like I'm thinking about every possible outcome when I'm trying to solve a problem. My mind just kind of automatically goes to the problem and which things I think will work. But computers work differently. Maybe my mind does do that, and it's just in the background, and it's just automatically throwing out things that it thinks are irrelevant. Is that how the human mind works? Maybe it is. Maybe it isn't. Maybe this is a totally new way of having intelligence. With the permission of code forces, we evaluated AlphaCode by simulating participation in 10 recent contests. The impressive work of the competitive programming community has created a domain where it's not possible to solve problems through shortcuts like duplicating solutions. Okay, so this is an assertion that they're making. I don't know if they're saying that it's absolutely true, but it's saying not possible to solve problems through shortcuts like duplicating solutions seen before, or trying out every potentially related algorithm. What that's saying is that you cannot solve these problems by just using what's already out there. And that's really interesting. I wonder how they're proving that that's the case. Instead, they say, our model must create novel and interesting solutions. Okay, cool. Overall, AlphaCode placed at approximately the level of the median competitor. That sounds pretty darn good to me. Although far from winning competitions, this result represents a substantial leap in AI problem-solving capabilities. And we hope our results will inspire the competitive programming community. Well, I don't know what to say about that. Will it? Does that inspire you? Does it inspire you to know that any potential career that you might have in coding could be taken away by an AI in the next few years, and anything that you come up with is probably going to be worse than what an AI is coming up with? Is that going to inspire people to join the industry? I don't know. All right, let's see what we've got here. This is kind of a graph that showcases where they are in different places. On the vertical axis here, we've got the data set that the problem solved, and we've got DeepMind progress. It looks like they're not very good at multi-query attention, encoder, decoder, encoder, MLM loss, code normalization, clustering. They're below average on all those. Ensembling, tempering, tags and ratings, value conditioning, scaling up. That's interesting. It's not really showing them above average in any one particular area. So maybe what that means is that they're below average in all the areas, but in aggregate, then they're approximately at the median. So that's interesting to note. For artificial intelligence to help humanity, Help humanity. That's interesting. Our systems need to be able to develop problem-solving capabilities. Yeah, that seems pretty obvious. AlphaCode ranked within the top 54% in real-world programming competitions, an advancement that demonstrates the potential of deep learning models for tasks that require critical thinking. These models elegantly leverage modern machine learning to express solutions to problems as code, circling back to the symbolic reasoning root of AI from decades ago. So I'd like to learn more about what that is. And this is only a start. Yeah, it really is only a start. Our exploration into code generation leaves vast room for improvement and hints at even more exciting ideas that could help programmers improve their productivity and open up the field. So this is kind of good here. They're saying could help programmers improve their productivity, open up the field to people who do not currently write code. This is a little bit more of a positive take than what I got out of the beginning, and maybe they're just trying to make people not depressed here, but if this is the case, then that's a good thing. It's going to help programmers improve their productivity by doing things that they don't want to do, and also open up the field to people who don't currently write code, because maybe you have a problem that you want to solve and you need someone to be able to help you solve it, and maybe an AI can do that. Maybe throw out my original thesis at the top of this episode, but it's possible that what this will do is actually open up the field of programming to more people. That is exciting. Maybe this could enable people to do things that we haven't been able to do before. And potentially it could allow people to stop doing things that we no longer want to do to progress onto more and more difficult problems. So maybe this isn't such a bad thing after all. We will continue this exploration and hope that further research will result in tools to enhance programming and bring us closer to a problem-solving AI. Bring us closer to a problem-solving AI. That's very exciting. So obviously you can view more of AlphaCode solutions and dive into the model at alphacode.deepmind.com. All right, guys, so after reading that, I'm a lot less scared and a lot more excited. Let me know what you guys think down in the comments below. Is this gonna make you want to invest in Google? I was actually looking at their share price just before I made this video, and they've been down quite a bit. They've been hit hard over the past 3 months, like basically all the tech companies out there. If they're working on these kinds of technologies that could rapidly scale and rapidly improve how people code, and they're able to solve these types of problems, like I think Google could be worth a lot more than what they're sitting at right now. What do you guys think? Let me know down in the comments below. Do you want me to do a valuation of Google? Do you want me to try and predict what this kind of stuff is gonna do for Google and what it could mean for the future of programming and for the stock price of Google? I don't know about you, but I'm way more excited than I was at the start of this video and feeling way less bad. So I hope you are too, and we'll talk to you guys in the next video. Peace.